I'm sorry not to be there in person today. I was really looking forward to being able to attend an OPAG in person finally. But at least the reason is the more mundane reason of traffic and commuting into DC, rather than some of the other reasons for not being able to participate in meetings recently. So maybe that's a step in the right direction at least. So I'm happy to give an update on where we are with Dragonfly. The team has been incredibly busy and making a lot of great progress, and so I've tried to cram a lot into this presentation just to let everyone know where we are. Dragonfly, of course, is a mission to understand the prebiotic chemistry that has occurred on Titan and to put that into the context of the Titan environment and the habitability of that environment. And I put this in part to remind me that there is a paper led by Jason Barnes, one of the deputy PIs on Dragonfly, that describes all of our science goals and objectives and level 1 requirements if people want more information about that. So to accomplish this science, we have a suite of instruments, mass spectrometer, 2 drills that feed that mass spectrometer, geophysics and meteorology sensor suite, a camera suite, and a gamma ray and neutron spectrometer. We're going to the equatorial dune region of Titan, where we can sample materials with a variety of geologic histories, including the sands in the dunes, the interdune materials with a water ice component, and then ultimately, of course, the objective is to get to the deposits associated with the impact crater, where these complex carbon-rich materials have had the opportunity to mix with liquid water, and we want to see how far that chemistry has progressed in this environment. Dragonfly, as I said, everyone has been very busy. We're coming up on our preliminary design review in October, and our subsystem and instrument PDRs are already underway. In fact, there's one going on right now. We have a series of these through the summer, leading up to our preliminary design review in the fall. So we've been working with NASA. Of course, there are budget realities that we're working in with respect to the NASA budget profile, and so we're working to accommodate that. And that had led to changes in our overall schedule. But the most recent schedule update that we've worked with NASA actually gives us the opportunity to have a shorter cruise trajectory. So we launch in 2027 and arrive at Titan by 2034. And this cruise trajectory, this shorter cruise gives us a lot of, there are a number of benefits to that, including higher power output from the MMRTG that we're designed to use upon arrival at Titan, which increases the science return of the mission. So, of course, in Phase B, we're in our preliminary design phase, focusing on technology maturation activities, defining the requirements, interfaces, and risk reduction. But the highest priority recently, over the last several years, has been, well, a few years so far, has been team safety under the pandemic conditions, which continue to limit some things in terms of activities, but we're glad to be able to be doing more and more in person as time goes on. We actually only have a few technical developments, and they're on track. We were actually able to eliminate 2 of them through design trades. We're also working to mature the concept of operations. In parallel, of course, we're already into the production of the Pika-D heat shield material for the entry vehicle for Dragonfly. And we've been doing a lot of work on the mobility subsystem, the subsystem that allows us to fly and navigate on Titan. And so we have we're wrapping up our progressive test campaign in Phase B that has demonstrated autonomous flight, takeoff, landing, and the optical navigation system. We're also working with NASA on the planetary protection and our communication plan, and the NEPA EA that was worked over the last couple of years actually had its public comment period this spring. So we're continuing ahead in all of these parallel activities and are on track with our technology maturation and definition requirements, and looking forward to mission PDR this fall. So I did want to show some of the work we've been doing. There's a lot of work to do testing, as well as modeling of aspects of the function, the lander itself and the entry vehicle in the Titan environment. I mentioned the mobility testing. We have about a half-scale integrated test platform, and this allows us to test aspects of the system. And we've been able to take this out now into the Imperial Dunes in the Southwest to be able to test the optical navigation in a system in an environment that is similar in terms of the imaging that we'll have to navigate on Titan flying over the dunes here. So that's been particularly exciting to see that system progress and to have now accomplished fully autonomous flights from takeoff through our scouting flights and leapfrog flights to autonomous landing. There's also a lot of development going on, of course, on the instrument side. The mass spectrometer development. There's a couple of pictures on the bottom left there, and then on the right, some of the testing and assembly of different components of the Draco sampling system on a vibration test there at the lower left, right. Dragonfly's camera system includes a set of LEDs that will illuminate the surface at different wavelengths. And so we've been doing testing of that system for the Dragon Cam suite. We also have been doing testing of the Dragons, the gamma ray neutron spectrometer as well. And we received just this year the prototype for the seismometer from JAXA, and so that's in testing as well. And one of the particularly exciting things, so this is our Titan pressure environment chamber that we built here at APL, and that's been here for a couple of years, and we've been doing a lot of testing in that. But just recently, just this year, we are bringing online the Titan is what we're calling it. So this is a larger chamber that will fit the entire lander within the chamber to be able to do testing under Titan conditions as well. So you can see it being it was installed outdoors and then brought inside, and this is actually just to give a sense of the scale of the chamber that is being outfitted right now at APL. So this is an APL investment. It is has capabilities for Dragonfly testing as well as future programs. So it's been really exciting to see that come together. In addition to all of the technical development, the team has been working to develop our rules of the airways. This is the Dragonfly rules of the road. And so that is something, it's of course a living document that is now in place for the entire team. And there's an annual review by all team members when registering for our annual team meeting. So so everyone is aware of this and expected to be participating, and following the rules of the airways. We have a working group that meets regularly as we've been defining this, but also as we move forward to making sure that the document is appropriate for all the, as we go through the different phases of the mission. We also have a student and early career guest investigator program. So we have 2 cohorts at this point. We have annual calls for about 3 positions in each cohort. Each cohort works with Dragonfly for 2 years. So we have our first 2 cohorts at this point, and we've had a number of presentations at conferences this year from students working in the program, which is really exciting. We also have just received applications for our 3rd cohort for selection this fall. So that's been a lot of fun and something we're really excited about as well. And we're looking for opportunities for community engagement. We've been able to do workshops and town halls at some conferences over the past year, and we're looking forward to future opportunities to do that. I already mentioned the Student and Early Career Guest Investigator program, but we also are looking forward in the future to NASA's Participating Scientist program. And we've been fortunate to be able to participate in the NASA Meeting Observer program the year before last, and we were partnered with Virginia State University in the Here to Observe program over this past academic year. And there's a picture here. We were really excited to be able to host the students. They made the 3-hour drive up, but we were able to host them here at APL and give them a tour at the end of the program that we've been working with them over the last year. So that was a great program, and we look forward to the future evolution of those opportunities as well. So that, I know, was a bit of a whirlwind of what we've been up to over the last several months with Dragonfly, but I'm also happy to take questions.
Thank you, Zibi. We certainly have time for some questions. Okay, we've got speaker approaching.
Hey, Zibi. This is Bethany Teeling again, NASA Goddard. So thanks for that update. That was really exciting. I'm particularly really excited to see your autonomous systems, your flight and navigation controls. So that's my question is maybe 2 parts. The first one is are you guys anticipating decision-making on the fly for unanticipated weather events? And then secondly, do you have any ability, is there any kind of autonomous ability to decide between targets? Or is that something that the team has to address in between? So it has these in-between stages.
Right. So the flights are relatively short. And with Titan's 16-day day and our nominal ConOps plan to fly once every other Titan day, we're actually flying for about 30 minutes once a month. So just to kind of put in context the how much time we're sitting on the surface doing science measurements, communicating with Earth, and how much time we're actually in flight. So in terms of weather events, we don't expect substantial weather at this time of Titan's year at this latitude, but we always know you can't count on the weather to do what you expect. The weather doesn't change that rapidly. So in a half-hour flight, again, we wouldn't expect there to be a change in the weather really from when we took off. But we absolutely have the autonomous capability to react and, land if anything untoward occurs, during flight. The navigation system actually constantly updates the closest, the top. I think it's about the top 3 and the closest safe landing sites that are identified by the system as we're flying. So it always has in its memory, where the closest landing site is. So there is built into the autonomous system the ability to put down if we need to. In terms of choosing sites, that is done with ground in the loop. So we have a leapfrog we have a leapfrog flight pattern where we always scout in advance the next landing site. And so from a given landing site, we'll fly kind of past where our next previously scouted landing site is to scout a new landing site and then come back to the previously scouted landing site. So because we can fly, we have the opportunity to actually scout things out in advance. And so then the decisions, and I'm sure the very animated discussions about where to go next will occur on the ground between flights.
Great, thank you.
Thank you. Any more questions online? Okay, we have time maybe to go back to a question or two. Well, okay, hold on.
Okay,
No. There you go.
hello.
Yes.
Anonymous asks, I've heard great things about the Dragonfly student and community engagement programs. Do you have plans to publish lessons learned?
That is, so let me see. I'm trying to answer that in too many ways all at once. We have developed, we've already published things in the form of abstracts. We do not have papers at this point, but we absolutely, that will be a great thing for us to do as we work through the program. There are a number of aspects of the implementation that it will definitely be useful to share our experience with the community. In particular, this is a program that's designed to broaden participation beyond students that already have connections to mission experience or even to planetary science, or at all. So it's really designed to reach beyond our community to provide connections to the broader community of students who haven't had opportunities to work with planetary missions, space missions before. So it's different in that sense from some of the other programs that a lot of us are familiar with, and so yes, it would be very good for us to publish on the lessons learned as we get through the first few cohorts here. Thank you.
We have time for one quick question.
Okay, super quick question from Leonard David on Zoom. Are you learning new things from Ingenuity that can be applied to Dragonfly?
There are a number of aspects of the missions, obviously, of the two missions that are commonalities. And so in terms of what they learned in their development and test cycles, and then in terms of their ConOps, because they too had completely autonomous ConOps on Mars. And so there are absolutely aspects of these that are parallel, and there's a great benefit to being able to communicate with, to be able to learn from their experience.